Okay, Caitlin, are you ready? This video is uploaded to my YouTube channel. It's also made for Caitlin. And so anybody that watches this, I hope you benefit for this. Caitlin, I hope that this is helpful for you as well. In this video, we're going to look at section, in this textbook, it's a McGraw-Hill textbook, similar triangles. And in the last couple of videos, we've looked at ratios and proportions. We've also looked at similar polygons. We're going to extend those concepts to triangles. First of all, the concept of similar. Okay, two figures are similar if they have the same shape, not necessarily the same size. So again, I can have a large version of a triangle and a small version of the exact same triangle. Those triangles are going to be similar. Let's call them A, B, C, and N, E, P. So triangle ABC, triangle NEP, those are going to be similar, assuming triangle A, let me write it this way, triangle ABC will be similar to triangle NEP if angle A and angle N are congruent to each other. Okay. Angle B and angle E are congruent to each other. Angle C and angle P are congruent to each other. Because again, the order here, A, B, I'm sorry, let me try that again. Forgive me. Angle A and angle N are congruent to each other. Angle B and angle E are congruent to each other. Angle C and angle P are congruent to each other. That's a little bit better. Okay. So we want to try to determine if two triangles are similar to each other. As long as the three angles of one triangle are congruent to the three angles of another triangle, then the two triangles will be similar to each other. Okay. So in the textbook over here, notice postulate 7.1 is the angle-angle similarity. So really, by rights, the triangles are similar to each other as long as the three angles of one triangle are congruent to the three angles of another triangle. But let's think about that. Is it really necessary to say that all three angles of one triangle need to be congruent to all three angles of the second triangle? Because after all, let's think about this. Let's say that we have triangle SJH and we have triangle DW. Oh, I can't use J again. Let's use N. Okay. Triangle SJH, triangle DWN. So let's suppose that we know that angle S is congruent to angle D. We also know that angle J is congruent to angle W. Okay. Well, let's just make this a little bit easier. And let's say that angle S is x degrees. If angle A is if angle S is x degrees, then angle D would also be x degrees if those two angles are congruent to each other. Let's say that angle J is y degrees, therefore angle W would also be y degrees. Now I don't know what angle H is, and I don't know what angle N is, and I'm not going to assume that those are the same. So since we're not going to assume that they're the same, let's say that angle H is A degrees and angle N is B degrees. Okay. Well, we would know that in triangle SJW that x plus y plus a degrees is 180 degrees. The three angles of triangle SJH adds up to 180 degrees. Excuse me. We'll try in triangle DWN. We know that x plus y plus b degrees would also equal to 180 degrees, would add up to 180 degrees because the three angles of a triangle add up to 180 degrees. Excuse me. So now I can subtract x and y from both sides, and a would equal 180 minus x minus y. Over here, I can subtract x and y from both sides, and b is 180 minus x minus y. And so you notice that a and b have the same value, so that we know that a is equal to b. So as long as two angles of one triangle are congruent to two angles of another triangle, the third angles are going to have to be congruent. So that maintains similarity. Okay. So let's look at example 1 here. A, are these two triangles JLK and MPQ, are they congruent to each other? And then write a similarity statement if in fact they are. So we have triangle JLK where angle J is 48 degrees. Had a little trouble reading it there. Angle J is 48 degrees. Angle L is 57 degrees. Then we have triangle MPQ. Not a great picture, but that's okay because angle M we know is 57 degrees. Angle P is 75 degrees. So what's the measure of angle K? Well, 57 degrees for angle L plus 48 degrees for angle J plus the measure of angle, excuse me, the measure of angle K needs to equal 180 degrees. So if I subtract 180 minus 57 minus 48, right, I'm subtracting the 57 and the 48 from both sides. So I'm subtracting 105 degrees from both sides. The measure of angle K is 75 degrees. So this is 75 degrees. To find the measure of angle Q, 57 degrees plus 75 degrees, what's that, 132 degrees, plus the measure of angle Q, that's going to add up to 180 degrees. Okay, so now I'm going to subtract 132 degrees from both sides. And the measure of angle Q is 180 minus 132, which should be 48 degrees. And now I notice that the three angles of the two triangles are congruent to each other. We have 48, 57, 75. 48, 57, 75. So since the three angles of one triangle are congruent to the three angles of another triangle, I know that those two triangles are congruent. Now to write my congruent statement, I'm sorry, not congruent statement, my similarity statement, triangle JLK is similar to, and now here, you ready, Caitlin? We need to make sure that this lines up. Angle J is 48 degrees. That's going to correspond to angle Q. Angle L is 57 degrees. That corresponds to angle M. And angle K is 75 degrees, which corresponds to angle P. And so there's my similarity statement. Okay. So let's look at example 1, part B here, because this does throw people off just a little bit sometimes because we have a little bit of a twisting factor going on. I call it a twisting factor here. Try to make this a little bit prettier. Okay. So here we have R, X, S, T, and W. And it appears to me that those two are not, those two triangles don't appear. It kind of looks like a bow tie, right? We've got the triangle on the left, over here. We've got the triangle on the right over here. They don't look like the same size. They might be, they may not be, and quite honestly, that doesn't matter. Okay. We also know, we're told, see those little red arrows there? So we're told that those two segments, Rx and TW, are parallel to each other. Because they're parallel, so I have these two parallel lines with a transversal, these two angles are congruent to each other. We also know, parallel lines with a transversal, that these two angles are going to be congruent to each other. And because we have two lines that intersect each other, the vertical angles, those two, are congruent to each other. So we know, therefore, that the two triangles are congruent to each other. I'm sorry, I keep saying congruent. The two angles are similar to each other because the three angles of one triangle are congruent to the three angles of another. So triangle, let's try to be tricky here. X, oh, let me do that. X, R, S. Okay, I'm using my colors here. That's similar to triangle. So X is the blue. That corresponds to or is congruent to angle T. Angle R is congruent to angle W. And then angle S here is congruent to angle S there. So triangle XRS is similar to triangle TWS. The order in which I write those letters, okay, is important. So Caitlin, you want to make sure that you get those in the right order because you're saying, again, that angle X is congruent to angle T. Angle R is congruent to angle W. And angle S is congruent to angle S. So you want to make sure that you get those in the right order. Okay, so there's some guided practice here. Excuse me, 1A and 1B that you can try. I don't want to bore you by doing everything for you or every single problem. That would make this video way too long. So I'm going to pick and choose a few that we can go through. So you'll notice here, there's two more theorems, side, 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 and side angle, side. And quite honestly, that's all based on what we've already talked about, okay? So if I can prove that the three sides of one triangle are in a similar proportion to the three sides of another triangle, then the two triangles are going to be similar. So as long as the three sides are similar, so we have a constant scale factor. If the ratio of JK to MP is equal to the ratio of JL to MQ and LK to OQP, then the two triangles will be similar. The same thing with side, angle, side. Okay. And then down here is the proof. I'm not going to redo that for you. Let's look for some application of that. There goes that magic hand grabbing and turning my pages for me. Okay, so bring this into focus just a tad there. Let's look at example 2A. Okay, so I have this diagram here. Angle P, Q, R, S, and T. It's quite a T. What do we know? We know that PQ is 6. We know that PR is 8 and QR is 5. We know that RT is 12.5. We know that RS is 20. And we know that TS is 15. And we're wondering if these two triangles are similar to each other. Okay. Now we don't have a statement like we had previous that PQ and TS, excuse me, that PQ and TS are parallel to each other. So we can't assume the same thing with the transversal and the alternate interior angles and that sort of thing. Okay. So we do know that those two angles are congruent to each other. Now, what I'm wondering is, what if we were to find the ratio of RS over RQ and compare that? Okay, so that's going to be RS over RQ. Let's compare that to RT over PR. So RS would be 20, RQ would be 5. That's 4 over 1. RT over PR is 12.5 over 8. And I can tell that that's not going to equal 4 over 1. I'm not going to get a constant scale factor. Now be careful. Don't give up here and say, oh, therefore the triangles are not similar. Okay. Look for a different pair. Okay. That's not going to work. So let's back up. Pretend that we can turn back the hands of time here. Get rid of all that purple and green. Clean up my diagram here. What if instead we look at RS over PR? That ratio is 20 over 8 or 5 over 2 because they both divide by 4. Let's compare that to TR over RQ. That's 12.5 over 5. Okay, that's going to look a little interesting, but I'm using my calculator here. If I divide 12.5 by 5, I get 2.5, which is 5 halves. Oh, we do have a constant scale factor. Let's compare that to TS and PQ. And that's going to give me 15 over 6, which they was both divided by 3, gives me 5 halves. So we do have a constant scale factor. So the 3 sides of one triangle are proportional to the 3 sides of another triangle. So by side similarity, I know that the two triangles are similar. The last thing I need to do here is to get a similarity statement. So triangle, I'm going to do the little one first. PQR is going to be similar to which triangle? And it's going to kind of go around. PQ is this segment from P to Q. QR is that segment, and RP is the third segment this way. We want to make sure that this lines up. PQ corresponds to ST. QR, right here, QR corresponds to TR. RP corresponds to RS. RP corresponds to RS. We want to make sure that we get those in the right order. And there is our similarity statement. Okay. So hopefully that makes some sense there. Okay. Now, let's look at example 2, because I want to do example 2 and I want to extend this one just a little bit. This one's a pretty interesting diagram. We have A, B, C, and E, F. Notice that AF is 10, FB is 5. AE is 8, EC is 4. Now, I want to compare this to these two triangles. The blue triangle, AEF, and the purple triangle, let's make it a red triangle, ACB. Okay, so let's separate those. We've got AEF, where AE is 8 and AF is 10. We then have the larger triangle, ACB or ABC, where AB is 15. You see how I get the AB is 15? This part is 10, this part is 5, the whole distance is 15. AC, this part is 8, this part is 4, so that's going to be 12. Now we know that angle A in this triangle here and angle A in this triangle here, those are the same. And I know that those are the same because they are the same angle up here in the original diagram. Now I wonder, is it true that AC over AE is equal to AF over AB? Well, AC is 12, AE is 8. AF is 10 and AB is, whoops, I'm sorry. Let's do that differently. Do you see what I did wrong here? AC is aside from the large triangle. AE is aside from the long. So this is large over small, red over blue. So in this ratio, since I did AC over AE for the first fraction, I should do AB over AF in the second. AC is 12, AE is 8. Those each divide by 4, and that's 3 over 2. So my scale factor is 3 over 2. AB is, whoops, my battery's going low. AB is 15, AF is 10. 15 divided by 10, 5 divides evenly into each of those. So I have a scale factor of 3 over 2. So I know that those two triangles are proportional. Okay. Now, because those, well, let's just keep going here. So I'm going to write a similarity statement. Triangle AEF is similar to triangle ACB. Okay. So there's my similarity statement. Okay. Now, something I want to extend a little bit farther. I want to go back to the original triangle, and I'm going to move this over and just make it clean. So what we just showed in triangle ACB, where this is 8, 10, 4, and 5. Because the ratio of 15 over 10 is equal to the ratio of 12 over 8, we were able to conclude that those two triangles were similar to each other, which means that this angle here is congruent to this angle. And these two angles are congruent. That's going to mean that these two sides are parallel to each other because I've got these two lines transversal. The corresponding angles are congruent. Therefore, these two sides are parallel. Okay. Now let me show you something else that's interesting. Since triangle AEF is similar to triangle what's going on here? To triangle ACB. You see this side here, AF is 10, AB is 8. That's 5 over 4. FB over EC has the same scale factor because those two triangles are similar to each other. Okay, so that's just a little interesting tidbit here in similar triangles, especially ones that are stacked inside of each other like that one. Okay, so this is kind of hard to see down here at the bottom of this page, but on the book here, 4A, right? So we've got this diagram with triangle MPO and then segment QN thrown in there. We're told that those are parallel to each other. Well, that means not only is angle M congruent to itself, but this angle Q and angle P are congruent to each other because of corresponding angles. Angle N and angle O would also be congruent to each other. So, excuse me, the large triangle MPO is similar to the smaller triangle. The larger triangle MPO, excuse me, the larger triangle MPO is similar to the smaller triangle MQN. And we know that this is 6, and this is 5. And again, I'm getting my information down here in the small triangle in 4A. And, if this is X, and O is 3 and 3/5. I'm going to, for now, call that 3.6. So what I know is, based on what I showed you above, right, based on what we did over here, whoops, where did it go? Up here. Because these two triangles are similar, 10 over 8 equals 5 over 4. Okay, where were we? So I know that 6 over 5 is equal to 3.6 over x. Or if I wanted to, 5 over 6 is equal to x over 3.6. And I could set that up either way, because to solve this, I'm going to cross multiply 6 times x, 5 times 3.6. 6 times x, 5 times 3.6. I'm going to get the same thing either way. 6 times x equals 5 times 3.6. 6x equals 18 divided by 6, and x is 3. So I can use that rule from similar triangles. Okay, let's do 4b for the heck of it. Okay, I'm gonna try not to go too long with this video either, but let's do 4b and look at this. So we've got this type of a situation. Here's W, S, R, V, T. Okay. WS is 8. WR is x plus 6. VT is 10. And this is 2x plus 6. Okay. Now it's really kind of hard to see here, but angle W's got a little mark in it, and angle T's got a little mark in it. So that's telling me that these two angles are congruent to each other. And we know that these two angles are congruent to each other. Okay, so angle, those two triangles are going to be congruent to each other. Before I go any farther, I want to write my similarity statement so that I make sure that I line things up correctly. Triangle WRS is similar to triangle. Now see, W is purple, T, angle R, so angle R, and then angle V. Now, we said before that means angle W is congruent to angle T. Actually, you know what? Let me do that differently. Angle W is congruent to angle T. Angle R is congruent to angle R, so that must mean that angle S is congruent to angle V, and that's true. But that also means that my ratio, the ratio of WR over TR, will equal the ratio of RS over RV, will equal the ratio of WS over TV. So those things line up. Okay. So here, WS is 8, VT is 10. So 8 over 10 is going to equal WR over TR, x plus 6 over 2x plus 6. I'm going to cross multiply. So 8 times 2x plus 6 equals 10 times x plus 6. And now I'm going to use my algebra, right? We all love our algebra, to solve this for x. So I'm going to distribute the 8 to the 2x and the 6. 16x plus 48. 10 times x, 10 times 6. So that's 10x plus 60. I'm going to subtract 10x from both sides, and at the same time, I'm going to subtract 48 from both sides. So 6x equals 12, or x equals 2. So that gives me the value of x. X equals 2. Well, if x equals 2, then this side would be 2 plus 6, or 8. And this side would be 2 times 2 is 4, plus 6 is 10. Okay, there's not enough information here at this point with your knowledge of geometry, I'm assuming, and what we've covered so far, that we can find SR in RV, but that will come later. Okay, so let's see what else we got here. So it looks like, as I look through these pages, that all of these things are going to be similar. So I'm going to encourage you to, if you are Caitlin, you have this book, that you practice these problems. The rest of you, try some of these problems. Contact me through my YouTube channel if you have questions, and I can go over a couple of these problems for you if you would like, but it's all extending the same problems. Okay, so that's similar triangles, extending the concept of ratios and proportions.